Hello, my name is Jonathan Silvis. This presentation will summarize some of the key points discussed in the journal written by Susan Palu and Hassam Mahmoud, titled Impact of Climate Change on the Integrity of the Superstructure of Deteriorated U.S. Bridges. First, I would like to talk about climate change. A general overview of climate change is that as more pollutants are released into the atmosphere over time, there will be more atmospheric temperature fluctuation worldwide. The importance of creating temperature resilient structures will also increase over time due to this fact. The focus of this study was on the deteriorated bridge structures that are currently in the U.S. The purpose of the study was to identify failing points of today's structures and propose recommendations for future engineers and policymakers to reinforce existing structures and build more resilient structures in the future. The primary resources utilized for the data collection in the study was the National Bridge Inventory, or NBI, and the National Oceanic Atmospheric Administration's climate change models obtained from the Geophysical Fluid Dynamics Laboratory. Additional structured data was obtained from on-site field inspections. The NBI was established in 1968 to document bridge locations, specifications, and condition after the Silver Bridge collapse in 1967. This catastrophic event cost the lives of 46 people. The data, once compiled, was disseminated using statistical techniques, applying a risk assessment associated with each condition, and establishing probabilistic modeling for each bridge. In short, with the combination of extensive resources and data computation, this study was able to assign a risk factor at different temperature ranges based on the bridge structural composition. All computations can be found in the full study. The study shows that climate change will have a profound effect on the current infrastructure. As weather condition continues to become more and more volatile, bridges become more susceptible to washouts and heat expansion issues. The greatest area of concern for bridge damage is the joint locations. These areas are most susceptible to expansion and contraction damage. While current building techniques were implemented and contrasted against the climate change models, it was determined that the structures were insufficiently designed to withstand the temperature changes for future climate change. The implications of a climate change on our current bridges will be significant. Inability to correct the issue will result in bridge failures. As seen in the Silver Bridge failure in 1967, this can cause catastrophic effects for the public. Bridge failure results in major economic costs. The structure will need to be repaired or replaced depending on the significance of the damage. There will be an associated disruption to the transportation network. This means rerouting traffic and the potential of communities to be cut off from supply chains. The inability to maintain these bridges will erode the trust of the public in authorities and public officials responsible for the public safety. Addressing these challenges requires proactive measures to ensure long-term viability in a changing climate. The study does give some recommendations to ensure the longevity of our current structures and the ones that will be built in the future. The importance of increasing the design standards of new construction bridges and retrofitting the current infrastructure is a critical first step. This includes using durable materials and innovative construction techniques. An example of a durable material is the steel composition I-beams that are used in new construction bridges. This allows for the contraction and expansion in the steel girders to be spread loaded across the entire structure. Regular inspection of the bridges will allow engineers to identify problem areas before they become too serious. It allows for documentation over time as the temperature changes due to climate change as well. Communication between the responsible authority and the local lawmakers ensure that funds are allocated to the restoration and installation of reliable bridge structures in the future. In conclusion, the study shows that climate change has a critical impact on deteriorated bridges in the United States. The research highlights the vulnerabilities of these structures and emphasizes the urgent need for strategies to address the challenges posed by climate change. It highlights the importance of proactive measures in maintaining and reinforcing bridge superstructures to ensure resilience in an ever-changing environment. Policymakers, engineers, and stakeholders must collaborate to implement sustainable solutions that enhance the durability of existing bridges and integrate climate resilience into future infrastructure development. The infrastructure network must be more resilient and sustainable to combat climate change. I would like to thank you for your participation in this presentation. Resources utilized in this presentation will be available on the last slide, along with my contact information if there are any questions. Again, thank you for your participation today.